So I'm Marc Baguelin. I'm going to talk about the school closure and varying social calendar. So what happens is that usually when you try to interpret school closure, you usually do it as something you have an epidemic and you close the school. But what happens in real life is that social contacts are varying, and that means that you have to include this into your models and to describe real life. So, in particular, during the 2009 pandemic in the UK, we had the beginning of the pandemic starting just before the school holidays from the summer. And what we were thinking about, that was a real sort of natural experiment to try to analyze. For this, we tried three different things. One was using a simple model to see if we could derive analytical results, which would be interesting. The second one was to try to use a more complex model, which include real life features such as risk group or age group, vaccination, and the real school calendar. And the last thing was to try to look at historical data to see if what we were predicting was actually happening. So in terms of the results, school vaccination seems to have reduced during the pandemic. The number of infection deaths by something at up to 30%, which is enormous. It's because the two waves of the pandemic in the UK was broken in a relatively similar size. So if you had a big epidemic, you would have the peak would have appeared during the summer, but it was at this period of time the contacts were much lower. This actually can be nicely analyzed analytically. If you derive some question, it's not possible to analytically solve even a simple SIR model, which is a more simple epidemic model. But you can derive things analytically, like the number of cases at the end of the epidemic, so by way of the root of an equation. And you can do the same by including varying contact. And then quite interesting is that the reduction is dependent on a single number, which is called A in that case. And this number is only dependent of a reduction in contact, the time of the closure, and quite interestingly, the average level of infections during this period of time. If you look at the pandemic, it's consistent with this. In the 2019-18 pandemic, the highest number of peaks you had at this time, the lower the cases, so you have a positive correlation with that. If you look at the calendar, depending on when you start the pandemic, you will have an impact which corresponds basically of the existing holiday. So,
time is up.
Okay. Yeah. Should I keep on?
Yeah, just conclude.
Yeah, and that means that there's an optimal way of reactive school closure. If you want to add a school closure, you should do it in order to maximize the number of cases during the school closure. That means that it can be detrimental to actually close the school when the epidemic is just starting, because that means that you're actually pushing up the last bit of the epidemic.